is 60, okay? Oops, what just happened? Angular triangle. So if you have 3 of the same angle inside of a triangle, you do 180 divided by 3, which is 60, okay? Now, if it's an equiangular triangle, what else do we know about that triangle? All the sides are the same. So this side is the same as this side, which is the same as this side. So all 3 of those are the same. Now, there's an equation that we can come up with right now based on that information. Savannah?
Based on, well, I was going to say, but it's, okay, well, now I'm confused myself.
Emma?
Okay, y equals 46 minus 16.
Or I would look at it as y plus 16 equals 46.
I guess.
Okay? So what we just did was we said, okay, this side, right, is these two added together, y and 16. Do you guys see that? That has to be the same length as this 46 because it's an equiangular and equilateral. Okay? If it's ever equiangular, it's equilateral. If it's ever equilateral, it has to be equiangular. Okay? One means the other. So since all the angles are the same, all the sides have to be the same. So 46 needs to be equal to 16 plus y. Okay? So we go ahead and solve this. What we get, people? Minus 16 minus 16. You get y equals 30. How many people got y equals 30? Good. Okay? All right, so we got y equals 30. But how do we find x? Mariana?
Is x saying the side of it or inside?
No, so since it has that degree symbol, it's going to be
Oh,
this angle right here. Okay? Savannah, what do you think?
Okay, so since there's no angle, like, it doesn't tell us what that third angle is,
Uh-huh.
we have to use linear pairs to figure it out. So we subtract 80 minus 180, so that angle's 100. And then you add 60 plus 100, and that gives you 160, and then you subtract 180, and x equals 20.
What? Wait,
Okay.
repeat that slower.
I'm going to repeat that whole thing. Savannah, that was amazing. Okay? Now, I'm going to repeat everything Savannah said, but super slowly. Okay? I want you guys to highlight this small little triangle right here. Okay? The reason we're highlighting this one is because one of the angles of this triangle is x. Do you guys see that? Okay? Now, we only knew to begin this problem that this angle was 60 and that this angle was x. But Savannah said, actually, we know that third angle because it's a linear pair with the angle that's 80 degrees, right? 2 angles that are a linear pair must add up to 180. So 80 plus this angle must equal 180. So 180 minus 80 gives me 100 degrees. So this angle needs to be 100, right? We also know that any 3 angles inside of a triangle need to add up to 180 degrees. So let's take the 3 angles that we have. We have x, we have 100, and we have 60. That should equal 180. We're going to get x plus 160 equals 180. You subtract 160 from both sides, and you get x equals 20. Okay, now, which, they all have to be 60. So we're going to put 60 degrees, 60 degrees, and 60 degrees. Guys, I'm going to highlight this triangle. What do we call a triangle that has all of the same angles? Equiangular. We can also say that those triangles are what? Equiangular triangles are also what, Mariana? Equilateral. So all of these sides need to be the same. So put a congruence mark on each of them. Okay? Now, it told us that this side up here is 20. Do you guys see that? So put a 20 wherever you see a side. That should be the same length. So this should be 20, this should be 20, and this should be 20. Why? Why am I able to do that? They're all congruent, but why? Why are they all congruent?
Because of the congruence.
They just have a mark, okay? They're all congruent because they have that mark. Now, the mark got extended to all of these three because it's an equilateral triangle, okay? But this mark up here is saying that this side has to be 20, so they all have to be 20. So our first equation is that 5y equals 20. You divide both sides by 5, and you get y equals 4. You guys with me?
Yes.
Okay. Now, what kind of triangle is the triangle on the right side?
The one with the isosceles. Oh.
I'm looking for a hand. Emma?
Isosceles.
It's an isosceles triangle. How did you know?
Because the two congruence marks are the two legs that are congruent.
Excellent. It has two congruent sides. So that means that it has two congruent.
What? Angles.
Angles.
I know what to do.
So look, this angle over here is going to be x degrees. But we still have no idea what this angle up here is. Emma, what do you think it is?
It's a linear pair, so you do 180 minus 60.
Okay. So remember, do you see how this 60 degrees with this angle will form a straight line?
Yeah.
That's a linear pair. So you just do 180 minus 60, and that'll give you that last angle. 180 minus 60, and that'll give you 120 degrees. But still, how do we figure out what x is? How do we figure out what x is? Dalila?
No, wait, where did the 60 come from?
So remember, whenever three angles are the same inside of a triangle, it's equiangular, it's always 60 degrees.
But like, oh, it's coming from that one, not the green one.
Not the green one, no.
Oh, okay.
Wait,
Emma?
Okay, so to find the two other angles, we do 180 minus 120 because all of them should equal 180, which gives you 60, and then you know that they were congruent, so you have to divide it by 2, which is 30.
Okay. Now, I'm gonna set up an entire equation, okay? X plus 120. The three angles inside of a triangle should always be equal to 180. So let's set 180 equal to x plus 120. Emma did the exact same thing that I'm doing, okay? She just didn't write it in as an equation, okay? You would subtract 120 from both sides. You would get 60 equals x plus x. You would get 60 equals 2x. Divide by 2, and you get 30 equals x. So in chapter 5, section 5, do you remember how we used SAS?
Oh.
We're using two new ones now, side, and hypotenuse leg, okay? Now, side congruence theorem is super easy. It's saying if three sides of one triangle are the same as three sides of another triangle, then those two triangles are congruent. And that makes sense, right? Because if you have a triangle where every single side matches up with the same sides of the other triangle, then they're congruent. Now, by saying that they're congruent, that's saying that all of the angles are also the same measure, okay? Is the same as DF, and BA is the same as DE. All right. So what we can write is that BA, this side, is congruent. Which side was congruent to BA? ED. That's one side. We can say that BC is congruent to EF. That's another side. And we can say that AC is congruent to DF. That's another side. So as long as we've got three sides that are congruent, we can apply the side theorem. for congruence and say that those two triangles are congruent to each other. Okay? Now, make sure you're very specific. You can't say that these two are congruent by the side angle side theorem, right? Because we aren't told any of the angles are congruent. Reasoning.
Wait, can you?
Oh,
okay.
Go.
Oh, we do ourselves. Okay.
Yep.
Oh no.
How many people think these two triangles are congruent? Raise your hands. How many people think these two triangles are not congruent? These are congruent. Why are they congruent though? Emma? Side theorem, okay? Side, a side, and a side are congruent to a side, and a side, okay? But you need to write the sides. So, FD is congruent to what?
JH.
JH, that's one side.
Wait, all of them?
Another side would be DG
And HK.
is congruent to HK, or KH, sorry, I reversed it. And then FG
JK.
is congruent to JK. And we can apply the side theorem. Right?
So you need to write all of them?
Oh yeah, every single one.
I did that last test and then you said we didn't need to do that.
Oh yeah, we still have to.
That was really weird.
If we're deciding whether the congruent statement is true. Okay? The other one that was on your test was, do you remember what it was asking?
No,
It just said write a congruent statement. So you would just need to write that congruent statement. This is our congruent statement right here.
So we're gonna need to do it on the test and then I think I.
Oh, did I? My bad. You go back.
Yeah, really quick.
You got it? Okay.
That's okay.
We're skipping this one. Okay. Example 2. Decide whether the congruent statement is true and explain your reasoning.
Wait, don't say it out loud.
Yes.
Sorry.
Okay. ABC,
Figure out yourself.
is that congruent to CAD?
Wait, hold on. A, C.
Xavier?
No,
No.
No.
Why not?
because DC and BA are not congruent.
Correct.
Wait,
B?
repeat. Oh.
No, those are congruent.
No? One says 4, one says 3.
Oh, that's CD and AB.
I said DCAB. Or I said DCABA.
Oh, you did?
Yeah.
My bad. So we say BA is not congruent to CD. Or not all sides are congruent. So therefore, the two triangles are not congruent. Make sense?
Wait. We're going on.
The 3 here and the 4 here. Say that one more time. Give me 3 congruent statements that involve sides. Give me one of them, Mariana.
PQ is congruent to SR.
Excellent. PQ is definitely congruent to SR. That's 1. We need 2 more. Emma?
PT is congruent to ST.
PT is congruent to ST. Love it. Janelle, give me the last one.
TR is congruent to Q. QT is congruent to T.
Very good. TR is congruent to QT.
Yeah, which one do you say first?
It doesn't matter.
Oh.
Okay?
It should matter orders.
Order matters like
matters.
order matters here
Yeah.
in the congruent statement. Okay? So up here, do you see in the congruent statement? That's where your order matters because Q has to match up with R, P has to match up with S, and T has to match up with T. When you're talking about the sides, as long as you're referring to the same side, like you can't say that PQ is congruent to ST. That would be wrong. okay? But you can say that PQ is congruent to RS, or you can say that SR is congruent to QP, however you want to write it. But you can't just match up not sides that are not congruent. Pressure, okay? A right triangle is any triangle that has a 90-degree angle, right? No, Jaden, you can't, okay? So this is 90 degrees. So this is a right triangle. The two lines, or the two sides that form the 90 degrees, we call those our legs, okay? And the side that goes at a diagonal is called your hypotenuse, okay? Your hypotenuse is going to be the longest side of your triangle. It's also opposite the 90 degrees. So draw a little line, or an arrow, pointing opposite the 90-degree mark, and that will always be your hypotenuse, okay?
Okay.
So, in the HL theorem, it says if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent.
Huh?
Okay?
Can you like dumb that down?
Oh, we're going to do an example. Okay? Hypotenuse and a leg of one triangle congruent to a hypotenuse and a leg of another triangle.
Like
Skip. Okay, so we're jumping back to example 5, okay? It says JKL has vertices J at -3, -2, K at 0, -2, and L at -3, -8. Before we do anything, let's go ahead and just plug in those points into our graph and see where JKL lies. So J was at -3, -2. It's right here. K was at 0, -2. And L was at -3, -8. So this is our graph. Let's label each of those points. It was J, K, and L, okay? And then R, ST is 10, 0, 10, -3, and 4, 0. And it says graph the triangles in the same coordinate plane, which we just did. Oh wait, R was 10, 0, sorry. R, S, and T. And then show that they are congruent, okay? So, in order to prove congruence, we know these are right triangles because whenever a horizontal and a vertical line meet, they are perpendicular. So here, angle J and angle R are perpendicular. So we know if we have right triangles, we can apply the HL theorem in order to prove congruence, okay? And HL theorem says, let's take the hypotenuse and a leg and see if they're congruent. And if a hypotenuse and a leg are congruent from both triangles, then we've got congruence, okay? Let's pick a really easy leg. Let's pick RS. And RS, the length of RS is 3 units. You can just count them. 1, 2, 3. Remember, vertical and horizontal lines, you can just count. 1, 2, 3. So RS equals 3. And then let's pick the corresponding side in JKL. And that would be JK. 1, 2, 3. So JK equals 3 as well. If two sides have the same length, then we can say RS is congruent to JK. Now, neither of those two sides were the hypotenuse, okay? So that falls under our leg category. Now, for the hypotenuse, we do have to use the distance formula to figure it out, okay? So we need to find the distance between K and L, okay? So we're gonna write KL equals the square root, and let's write in the coordinates. K was 0, -2, and L was -3, -8. Okay? Remember, you make one of your coordinates x1, y1. You make the other coordinate x2, y2. Okay? And we're going to do x2 minus x1. So 0 minus -3 squared plus y2 minus y1. That's a y, by the way. My handwriting's getting sloppy. y2 minus y1, so it would be negative 2 minus negative 8 squared. So KL equals the square root. 0 minus negative 3 is going to be positive 3 squared, plus negative 2 minus negative 8 is going to give me positive 6 squared. So this is going to be KL equals 3 squared is 9. 3 times 3 is 9, plus 6 times 6, which is 36. So we've got KL equals the square root of 45, which actually simplifies, okay? 45 is divisible by 9 and 5. So KL equals, the square root of 9 we know is just 3, so it's 3 times the square root of 5. Okay, now we have to see if that hypotenuse is congruent to the hypotenuse of RST. So we need the coordinates for S, which are 10, negative 3. And we need the coordinates for T, which are 4, 0. And then we need to find the distance between them, okay? So we're going to make one x1, y1, and the other one x2, y2. Remember, whichever one you make which, it doesn't matter, okay? So let's go ahead and apply the distance formula. ST equals the square root of x2, which is 10, minus x1, which is 4 squared, plus y2, which is negative 3, minus y1, which is 0 squared. So we're going to get ST equals the square root of 6 squared plus negative 3 squared. ST equals the square root of 6 times 6, which is 36, plus negative 3 times negative 3 is going to be positive. We got ST equals the square root of 45, which we just said simplifies to ST equals 3 times the square root of 5. So these two are also the same length, so we can say that they're congruent. So we would say that our hypotenuse, which are KL, is congruent to ST. And we can say that these two triangles are congruent by the hypotenuse leg theorem, okay? You could have also used the side theorem, okay? And if you didn't recognize that they were right triangles, and you could have said that RT is 1, 2, 3, 4, 5, 6 units, and JL is 1, 2, 3, 4, 5, 6 units. So that would have given us 3 congruent sides, which would have applied the side theorem, okay? Let's just go ahead and fill in. This is 3 times the square root of 5. This is 3 times the square root of 5. This one for now, okay? Let's go to this one.
Okay.
Example 6. We're going to do example 5 tomorrow. Is there enough information to prove that the triangles are congruent?
Yes.
If so, state the theorem or postulate. First thing you need to check, okay? Are we talking about right angles?
Yes.
Yes. So write right angles, right triangles,
Right triangle.
and put a check mark. Next thing you need to check, do we have hypotenuses that are congruent? Put an H. Let's identify what our hypotenuses are. Emma?
FH,
FH and KH. Are those congruent?
KH.
Very good. So we write FH is congruent to KH. How do we know that those are the hypotenuses?
Oh, the longest.
And they're opposite the 90, right? Okay. Do we know that a leg is congruent?
Yes.
We sure do. We know that JK, is congruent to GH. So we can apply the HL theorem to prove congruence.
Okay.
So
Yes.
yes, so write right triangles Put a check. Do we have congruent hypotenuses?
Yes.
Yeah, BD as a hypotenuse is congruent to AC, right? Put a check. Do I have congruent legs?
Yes.
Why?
Because they're the same one.
AB.
BC is congruent to
CB.
BC
Oh,
itself.
okay.
So can we apply the HL theorem?
Yes.
Sure can, HL theorem.
Perfecto.
Turn the